Brain Rules: 12 Principles for Surviving and Thriving at Work, Home, and School by John Medina. Picture this: a 70-year-old man standing at the edge of Long Beach Harbor in California. He's not there for a leisurely stroll or to admire the boats bobbing in the water. What he's about to attempt would make most people half his age think twice. He's handcuffed, shackled, and attached to a cable, and at the other end, 70 boats, each carrying a person. Then he dives in and starts swimming. Fighting against strong currents, he tows all 70 boats and all 70 people for 1.5 miles across the harbor. This incredible human was Jack LaLanne, and this wasn't just a random stunt. It was his 70th birthday celebration. But here's what's even more amazing than his superhuman strength. Well into his 90s, his mind was sharper, his wit quicker, and his energy more vibrant than people 3 times younger. So here's the million-dollar question: is there really a connection between a healthy body and a healthy mind? And if that's true, what other secrets is our brain hiding that we've been missing all along? For centuries, the human brain has been the ultimate mystery. It's this incredible 3-pound universe tucked inside our skulls, responsible for every thought, every emotion, every memory we've ever experienced. Yet somehow, we're all walking around with this phenomenal machine and absolutely no instruction manual. We spend our entire lives with it, but most of us have no clue how it actually works. That's exactly what Dr. John Medina, a developmental molecular biologist, decided to tackle. He spent his career studying the intricate choreography of genes and molecules that construct our brains, but what really drives him is connecting brain science to our everyday lives. And he noticed something fascinating and frustrating. The places where we're supposed to do our best thinking, schools and offices, are often set up in ways that completely contradict how our brains are designed to learn. It's like being handed a Ferrari and told the best way to drive it is to stay in first gear forever and skip all the maintenance. So he wrote Brain Rules. This isn't just another collection of cool neuroscience facts. It's your brain's missing instruction manual, based on decades of solid, peer-reviewed research, translated into simple, powerful principles that can transform how we work, learn, and live. By the time we're done today, you'll understand why multitasking is basically impossible, like trying to pat your head, rub your belly, and solve calculus problems all at once. You'll discover why exercise might be your secret weapon for getting smarter. And you'll learn why a simple 26-minute nap could boost your performance by 34%. Here's my promise: you're about to get the owner's manual you never knew you needed. Let's dive in. To really understand how our brains work, we need to take a trip back in time, way, way back. Not just centuries, but millions of years, to the grasslands of the Serengeti. Because our brain's story begins with one simple fact that every scientist agrees on: we moved a lot. Our ancestors weren't sitting in classrooms or stuck in cubicles. They were walking, sometimes up to 12 miles a day, through an unpredictable, ever-changing outdoor world. This incredible thinking machine we call our brain wasn't forged in a library. It was shaped in the wilderness, while constantly on the move. Dr. Medina calls this the brain's performance envelope. It's designed to solve problems related to survival in an unstable environment while moving. Every rule in this book flows from that core truth, which brings us to the first, and possibly most important, brain rule: exercise boosts brain power. When you think about exercise, you probably picture building muscle or improving cardiovascular health, but the most dramatic effects of exercise happen in your brain. Remember Jack LaLanne? His story isn't just some weird outlier. It's living proof of what science has confirmed. When we move, blood flow increases throughout our body, including our brain. This delivers 2 things our brain desperately craves: glucose for energy and oxygen to clean up all the toxic leftovers from thinking. Think of it as a world-class delivery and cleaning service for your head. But it gets even better. Exercise triggers the production of a protein with the wonderfully nerdy name of brain-derived neurotrophic factor, or BDNF for short. The easiest way to think about BDNF? It's like Miracle-Gro for your brain cells. It keeps your existing neurons healthy and encourages the growth of new ones, especially in the hippocampus, the region that's crucial for memory and learning. The research is absolutely stunning. A lifetime of regular exercise can lead to remarkable improvements in cognitive performance, memory, reasoning, attention, problem-solving, all of it. Even better, it's one of the most powerful forms of preventative medicine we have. Just exercising aerobically twice a week can cut your risk of general dementia in half. And it can reduce your chances of developing Alzheimer's by more than 60%. We've built our modern world around sitting still, but our brains are literally screaming to return to their Serengeti roots. We weren't designed to plant ourselves at desks for 8 hours straight. We were built to move. This ancient history didn't just shape our need for movement. It shaped the actual architecture of our brains and our unique way of thinking. Which leads us to our second rule. The human brain evolved too. If you could peek inside your skull, you wouldn't find one brain. You'd find 3, stacked on top of each other like layers in an archaeological dig. At the very bottom is the lizard brain, the brainstem that controls basic survival functions like breathing and heartbeat. Wrapped around that is the mammalian brain, which manages our emotions, memories, and what scientists delightfully call the 4 F's: fighting, fleeing, feeding, and, let's just say, reproductive activities. And then, like a thin, wrinkled blanket covering everything, is the cortex, the human brain, where logic, reason, and our most complex thoughts live. So what made our brain so special? When climate change pushed our ancestors out of the trees and onto the savanna, we faced a choice: get stronger or get smarter. We chose smarter. Instead of developing bigger muscles, we developed bigger brains. And that new brain power gave us a superpower that no other creature possesses quite like we do: symbolic reasoning. It's what happened when my 4-year-old son Noah picked up a stick and declared, "That's not a stick, that's a sword!" He could see one thing, but understand it could represent something completely different. This ability to make one thing stand for another is the foundation of everything that makes us human: language, art, mathematics, culture. We are human because we can imagine. But perhaps our greatest evolutionary trick was learning to cooperate. On our own, we were pretty weak, but together, we could take down a woolly mammoth. To work together effectively, we needed to understand what others were thinking and feeling. We developed something called theory of mind, the ability to peek inside someone else's head and guess their intentions. This social intelligence, this deep need to connect and predict others' behavior, might be what drove the massive expansion of our brains. At our core, we're built for relationships. And here's a critical insight about learning. If you don't feel safe with your teacher or your boss, you might not be able to learn or perform well. Learning isn't purely intellectual, it's emotional. Our brains evolved to learn from people we trust. This deep history explains not just why we learn, but how we learn. Which brings us to a fundamental misunderstanding most of us have about our own minds. When you learn something, where does it go? Does your brain work like a video camera, perfectly recording events for later playback? Not even close. The truth is, the moment information enters your brain, it's like it's been tossed into a blender with the lid off. The information gets sliced into pieces and scattered all over your cortex. The sights, sounds, and smells of an experience are stored in completely different parts of your brain. Your brain doesn't even store vowels and consonants in the same location. This is the opposite of recording, it's reconstruction. Every time you remember something, your brain is reassembling those fragmented pieces. And this leads to our third rule: every brain is wired differently. What you do and learn in life physically changes your brain's structure. It literally rewires itself. A violinist's brain looks different from a basketball player's brain. The regions controlling their left-hand finger movements become enlarged and more complex, like a muscle that's been thoroughly worked out. This rewiring happens constantly, and it's unique to you. Not even identical twins who share the exact same DNA have identical brain wiring. Why? Because from the moment they're born, they have slightly different experiences. They see the world from different angles. They learn different things at different times. Every second of your life, your experiences are sculpting a brain that's completely unique in the cosmos. There's no such thing as a standard brain. We each have different strengths, different forms of intelligence that don't always show up on IQ tests. Yet our school systems are often built on the idea that every 10-year-old brain should learn the same way at the same pace. But brain science tells us this is fundamentally wrong. It's like expecting every basketball player to be a great three-point shooter. Some excel at defense, others at passing. Think about Michael Jordan, arguably the greatest basketball player ever. In 1994, he quit basketball to play professional baseball. He failed spectacularly. His brain was wired for the split-second decisions and movements of the basketball court, not for hitting curveballs. The lesson? We need to create environments, in schools and workplaces, that honor this diversity, that help people play to their strengths, instead of forcing everyone into the same mold. So if every brain is different, and learning is this chaotic reconstruction process, how do we make anything stick? This brings us to the engine room of learning, attention and memory. Let's start with a rule everyone knows intuitively but consistently ignores. We don't pay attention to boring things. Your brain is constantly bombarded with millions of sensory inputs every second. It has to make choices about what's important and what's not. And what captures your brain's attention? Emotion. Think about your most vivid memories. I bet they're tied to strong emotions. Joy, fear, surprise. Emotionally charged events act like a chemical sticky note for our brains, releasing dopamine that essentially says, "Remember this." Dr. Medina tells a harrowing story about waking up in the middle of the night to find an intruder in his house. The experience lasted only 45 seconds, but the details are burned into his memory forever. What scientists call emotionally competent stimuli are the most thoroughly processed information we ever encounter. This is where most lectures and presentations go wrong. An audience's attention has a shelf life. Studies show that in a typical presentation, you've got about 10 minutes before people start mentally checking out. After 9 minutes and 59 seconds, you need to do something to recapture their attention. Something emotional, something relevant, something that acts as a hook to reset the clock. And here's another truth about attention that might revolutionize how you work. The brain cannot multitask, at least not when it comes to paying attention. What we think of as multitasking is actually rapid task switching. Every time you switch attention from your homework to a text message and back, your brain goes through a 4-step process. Disengage from the first task, alert itself that it's shifting, activate the rules for the new task, and then engage. This process isn't free. It costs time, several tenths of a second for every switch. Studies show that when you're interrupted, you take 50% longer to complete a task and make up to 50% more errors. Trying to talk on a cell phone while driving? It's not just dangerous. It's as impairing as driving drunk. Your brain is a sequential processor, one thing at a time. That's the rule. Once you've captured your brain's attention, how do you turn that fleeting moment into a lasting memory? This leads us to two of the most practical rules. Rule 5, repeat to remember, and Rule 6, remember to repeat. Most of what we learn evaporates within minutes. Think of your short-term or working memory as a small desk, where you can process a few pieces of information at a time. The typical brain can hold about 7 pieces of information for less than 30 seconds. If nothing happens to that information in those 30 seconds, it disappears forever. So how do you move information from that temporary desk into the vast long-term storage of your brain? The secret is repetition. But not just any repetition. Cramming information all at once is like trying to stuff a week's worth of groceries into a tiny refrigerator in one go. It's messy and inefficient. The most powerful way to cement a memory in your brain is through spaced repetition. Learning works best when new information is incorporated gradually and repeated at timed intervals. When you first learn something, the memory is fragile. If you deliberately re-expose yourself to that information after some time has passed, a few hours, then a day, then a few days, the memory becomes stronger and more durable. This process, called consolidation, can take surprisingly long. The conversation between the hippocampus, where short-term memories are processed, and the cortex, where long-term memories live, isn't a quick chat. It's a dialogue that can last for years. This is why homework at its best is so valuable. It's forced repetition. An even better system would build this repetition directly into the school day, reviewing information cyclically and deliberately. Of course, for any of this to work, your brain needs to be in the right state, which brings us to two of the most overlooked aspects of mental performance: sleep and stress. Let's start with Rule 7. Sleep well, think well. We spend a third of our lives sleeping, yet most of us treat it like a luxury, or, worse, a waste of time. Brain science tells us this is a massive mistake. When you're asleep, your brain is anything but resting. It's buzzing with activity, with neurons firing in rhythmic patterns, often replaying and processing what you learned during the day. What's really happening during sleep is a battle between two opposing forces in your head. One army, the circadian arousal system, is doing everything possible to keep you awake. The other, the homeostatic sleep drive, is trying to put you to sleep. This war cycles every 24 hours. The longer you're awake, the stronger the sleep drive becomes, until it finally wins and you fall asleep. And the longer you sleep, the stronger the arousal system becomes, until it wins and you wake up. Sleep loss isn't a badge of honor, it's brain drain. Losing sleep cripples your attention, executive function, memory, logical reasoning, nearly every cognitive function we can measure. One bad night can decrease your cognitive performance by 30%. Restrict yourself to 6 hours of sleep nightly for just 5 days, and your brain will perform as if you've been awake for 48 hours straight. What about that groggy feeling around 3 in the afternoon? That's not just you. It's a universal biological signal called the nap zone. It's when the battle between your two internal armies reaches a stalemate, and your brain desperately wants a break. Fighting through it is often futile. The science is clear. A short nap can dramatically boost performance. A NASA study found that a 26-minute nap improved pilot performance by 34%. So next time you feel that afternoon dip, remember, your brain isn't being lazy. It's asking for what it needs. Just as sleep is essential for a healthy brain, the wrong kind of stress can be devastating. This is Rule 8. Stressed brains don't learn the same way. Our bodies have an amazing stress response system. When faced with a threat, like a saber-toothed tiger, your brain signals your adrenal glands to release adrenaline and cortisol. This is the fight-or-flight response, designed for short-term, life-threatening situations. It prepares your body to act fast. The problem? Our modern lives are filled with chronic stress. Work deadlines, traffic, financial worries, relationship conflicts. Our stress system wasn't built for that. When stress hormones like cortisol stick around too long, they become toxic. Adrenaline can scar your blood vessels, leading to heart attacks and strokes. And cortisol is particularly damaging to the hippocampus, that critical region for learning and memory. It can disconnect neural networks, stop new neurons from being born, and under extreme conditions even kill brain cells. What's the worst kind of stress? The feeling that you have no control over the problem. This is the essence of learned helplessness, where the brain essentially gives up. This has huge implications. An emotionally unstable home is one of the biggest predictors of poor academic performance, because it creates chronic, uncontrollable stress for a child. The same applies to workplaces. The most toxic work environment is one with high demands but low control. Our brains don't just process abstract thoughts. They experience the world through a rich tapestry of senses. But we don't treat our senses equally. This brings us to the next set of rules about how we perceive our world. Let's start with Rule 9. Stimulate more of the senses. Our senses didn't evolve in isolation. They evolved to work together, constantly influencing each other to create a unified picture of reality. You can see this in something called the McGurk effect. If you watch a video of someone saying the syllable ga, but the sound you hear is ba, What do you perceive? Your brain, trying to resolve the contradiction, will likely hear "da," a complete fabrication, a compromise between what it sees and hears. Because our brains are built for a multisensory world, we learn best when we engage multiple senses at once. Students taught with both words and pictures learn better than those taught with words alone. In one study, groups given multisensory presentations came up with 50 to 75% more creative solutions than groups receiving information through just one sense. The effect is supra-additive, meaning the whole is greater than the sum of its parts. Of all our senses, smell holds unique power. Odor signals bypass the brain's normal sensory switchboard, the thalamus, and go directly to key areas like the amygdala, our emotional control center. This is why a certain smell can trigger a vivid, emotional memory from years ago, the Proust effect. But even with all our senses working together, one sense dominates. This is Rule 10. Vision trumps all other senses. Vision is by far our most dominant sense, consuming a staggering half of our brain's resources. We don't see with our eyes. We see with our brains. And what we perceive isn't a perfect camera-like recording of reality. It's an interpretation, a best guess, based on incomplete information and past experiences. Your brain constantly fills in gaps and makes things up. For example, each eye has a blind spot where the optic nerve connects to the retina. You should see two black holes in your vision, but you don't. Why? Because your brain examines the surrounding information and paints in what it thinks should be there. You are, in a very real sense, hallucinating right now. Because vision is so dominant, it profoundly affects our other senses. Remember those wine tasters? A group of experts at the University of Bordeaux were given a white wine colored with a tasteless, odorless red dye. Every single one described it using vocabulary for red wines. Their eyes completely overrode their highly trained noses and taste buds. This visual dominance has a huge impact on learning. The pictorial superiority effect is one of psychology's most robust findings. Simply put, we remember pictures far better than words. If you hear information, you'll remember about 10% of it 3 days later. Add a picture, and you'll remember 65%. Why is text so inefficient? Because to your brain, words are just collections of tiny, complex pictures. Your brain has to identify every feature of every letter before assembling the word. Reading creates a bottleneck. This is why text-heavy PowerPoint presentations with endless bullet points are among the worst possible ways to communicate. Our brains simply aren't designed for it. We've discussed how our brains evolved, learn, wire themselves, and perceive the world. But we've saved one of the most powerful and hopeful rules for last. It's most visible in the youngest among us, but it's a rule that never has to leave us. This is Rule 12. We are powerful and natural explorers. If you want a model for how humans are designed to learn, don't look at a college classroom. Look at a baby. Babies aren't passive sponges just absorbing information. They're active scientists. From birth, they're driven by insatiable curiosity, an intense need to understand their world. They learn by doing what scientists do: observe, form hypotheses, design experiments, and draw conclusions. When a baby repeatedly drops a spoon from her high chair, she's not just making a mess, she's testing gravity. When a toddler points at a bee after being told it's dangerous, then grabs it the second you turn away, he's running an experiment on cause and effect and your attention. This drive to explore is so deeply woven into our brains that it persists throughout our lives, if we let it. We now know that parts of the adult brain remain as flexible and malleable as a baby's brain. We can continue growing new connections, and even new neurons throughout our lives, allowing us to be lifelong learners. Nobel Prize-winning scientists Edmund Fisher and Edwin Krebs were still running powerful, productive labs well into their 70s, driven by the same boundless curiosity they had as young men. The tragedy is that our educational and corporate environments often crush this natural exploratory instinct. From first grade, we learn the goal isn't curiosity but getting an A. We learn to ask, what do I need to know to pass the test? Instead of, what fascinates me? But it doesn't have to be this way. Companies that thrive, like Google, with its famous 20% time for employees to work on any project that interests them, understand that curiosity fuels innovation. Our brains weren't built for boredom. They were built for wonder. They were built to explore, question, experiment, and never stop learning. As we've journeyed through these 12 rules, a single powerful idea emerges that I believe is the heart of John Medina's message. Our brains have a quote, factory setting. For millions of years, they were optimized for a specific type of world, one filled with movement, constant threats, and rich, multisensory experiences. The modern world we've built, our schools, offices, cities, is a radical departure from that original design. Much of our frustration, inefficiency, and struggles with learning stem from this fundamental mismatch. What Brain Rules offers isn't just a list of tips and tricks. It offers a path back to ourselves. It gives us permission to work with our brains instead of constantly fighting against them. It reminds us that we're biological creatures shaped by an ancient past, and honoring that biology is the key to unlocking our full potential. This book is a quiet revolution. It challenges us to rethink everything. Why do we force students to sit still for hours when we know their brains learn best in motion? Why do we cram presentations with bullet points and text when we know vision is our most powerful sense? Why do we praise multitasking when we know it cripples productivity and increases errors? The most profound lesson for me is about exploration. In a world that often prizes conformity and specialization, Medina reminds us that our greatest strength is curiosity. That scientific, hypothesis-testing instinct we see so clearly in babies isn't something we're meant to outgrow. It's the engine of learning and discovery. It's what allows us to adapt, innovate, and find joy in the lifelong process of understanding our world. This book is a call to protect that instinct in our children and rediscover it in ourselves. So how can you start applying these powerful ideas to your own life right now? It doesn't require a radical overhaul. Small changes aligned with your brain's natural tendencies can make a huge difference. Here are 3 simple things you can try today. First, embrace movement. If you're stuck on a problem or trying to learn something new, get up and walk. Our brains don't just work better when we exercise. They think better when we move. Don't separate your physical life from your mental life. Integrate them. Second, honor the 10-minute rule. Whether you're studying for an exam or sitting in a meeting, your attention works in 10-minute bursts. When you feel your focus waning, don't just push through. Take a 60-second break. Shift your focus. Look at a picture related to the topic. Ask a question. Do something to re-engage your brain before diving back in. And third, think in pictures. Our brains are visual processors above all else. When you want to remember something, don't just write it down. Draw it. Create a mental image. The more you can turn abstract information into a visual story, the more likely you are to remember it. That was a summary of Brain Rules by John Medina. We've touched on the key principles today, but I have to be honest. Listening to a summary is like looking at a travel brochure. It can show you the sights, but it can't replace actually taking the journey. The real magic of this book is in the stories, the science, and the aha moments that happen when a particular idea connects with your own life in unexpected ways. This summary is your map, designed to help you see if this journey is worth taking. If anything we've talked about has sparked your curiosity, I encourage you to grab a copy. Reading it isn't just about learning facts about your brain. It's about starting a conversation with it, and that's an experience that can genuinely change how you live. And if you found this summary valuable, please take a moment to like and subscribe. Each week, we dive into another life-changing book from some of the world's most brilliant minds. By subscribing, you're not just joining a channel. You're joining a community of lifelong learners. Let's keep exploring together.